let's record it for posterity. Homework quiz, a week from today, master set, due a week from Thursday.
And that's master at 23, correct?
Yes, that's correct, which I've had one handed in already. Any questions?
When are we gonna start chapter 24? I'm guessing after we do 23 quiz.
No, we're starting 24 now. I generally assign, I should have assigned it last week for the quiz to be on Thursday, but I didn't, so we're here now.
So electric field lines always go in the positive direction, even if there's uniform field.
The electric field lines,
I was reading something about that last night.
yeah, I don't think electric fields are in chapter 23 at all. So.
Oh, I thought you said we were starting 24.
Yeah, that's electric fields.
Oh, yeah, that's what
Okay. You said in fact, the electric field lines always go in the positive
direction.
Not necessarily, because positive direction is depending upon the person solving the problem.
No.
There's an arbitrariness. I'm suddenly thinking of, I'm trying to read your mind. I'm having difficulty. We'll
I
get to
had
it.
some problem last night that I was like trying to do, and it involves electric fields, but I don't remember.
Well, perhaps it'll be resolved after
Yeah.
the first part, and feel free to ask it again if it's not addressed. Because what you said, I can interpret it one way where I could answer it yes, but another way where I'd answer it no, so that's why
Okay.
I was having difficulty. All right, so let's start out with the universe. Creating the universe. This is a positive charge in it. Sitting there, fat, dumb, and happy. I put a negative charge into it. What is that negative charge going to do?
Reward each other.
Say it again.
Reward each other.
Yes, okay. How does the negative charge do the positive charges there?
There's a force,
What?
like,
Just know.
In order for there to be a force, suddenly it shows up and the positive charge goes, ooh, I'm sensing a disturbance in the force.
Does that have to do with like electrons and protons?
Well, we could connect it to that, not necessarily, not where I'm going right now.
It has a presence,
Pardon?
like a presence,
What has a presence?
the two charges.
They have a presence, that it senses the presence. Okay, I'll go with that.
does it really know though?
It doesn't really know, but somehow it's going to be attracted. It's going to start. If this is sitting here, I put this into this universe at rest. It is going to start moving towards it. But how does it? It has to have some sense of there's something over there to be attracted towards. And so the idea is that before this comes in, the positive charge exudes a presence. And the negative charge is picking up on that presence. Now, the presence, we of course have a name for. That is the electric field. So the idea is that there is something the positive charge is giving off, and I'm the only one, except maybe some former students, who will say this. It's kind of like the electric pheromones. then it's giving off, and the negative charge is put into it, and it senses the pheromones and goes, ooh, I wonder what's causing that. So whatever it is that it's giving off, it's gotta be related to the force, but at the same time, it can only involve one charge. And so you can go through I know that the force between the charges but since the electric field can only deal with one charge, because again, we're making the claim that it exists before the negative charge even shows up. Because otherwise, we're still left with the question of, if it doesn't give off the electric field before the negative charge shows up, how does it know when to start? And so what we do is just get rid of one of the charges. So if I do the electric field acting on, the electric force acting on 1 from 2, divided by the charge at 1, we end up with Kc Q2 over R squared, R2 hat. And this would be the electric field created by charge 2. Now, when they first came up with this idea of the electric field, they had no idea if it was true or not. It would be, I think they came up with the idea of electric field in the early 1800s, and 1870s is when they finally said, oh, wow, it actually worked. It is true. There's a bunch of stuff that people come up with that ends up not being true and doesn't make it into the textbooks. As one fellow graduate student said, he was working on this dissertation that he was not told when he started that there's a 1% chance of it being incredible and a Nobel Prize, 99% chance that it was pure crap. It turned out to be pure crap. So you throw it over against the wall, hailed as a genius, if later on they find out you're telling it's true, and fall into the dustbins otherwise.
If you're writing a dissertation like that, just write it.
Say it again?
If you're writing a dissertation like that and it turns out to be crap or like be completely untrue, do you have to restart and make a new one, or can you just submit your untrue dissertation?
It is possible to submit one, depending upon the nature of it, but you can submit it showing that something is not true. It's harder to do that. Yeah, my dad has an EDD, or had, he's gone, so I don't know if it's present tense or past tense there. Has an EDD, educational doctorate, and his conclusion at the end was opposite of what he thought he was going to show. And it tacked on another 6 months just to make sure he was taking everything into account.
So Q2 is the positive charge?
Q2 is the second charge. So in this particular case, if we're looking at what's acting on this would be Q2 and then Q1.
So Q1 doesn't have an electric field too?
Oh, it does also. The electric field produced by 1 would be KCQ1 over R squared R1. Or in general, the electric field created by a charge, the electric field from a charge is that constant times the charge divided by the distance squared. And then the radial unit vector is in reference to whatever the charge is, wherever the charge is. So in this scheme here, charges are attracted to each other not because they are opposite charges, but because the charge senses the electric field and either goes to investigate or runs. And what I mean by that is, if I have an electric field moving to the right here, I can come up with 3 reasons for this. Well, actually, before I get to that, one other thing. Radial unit vector, away from the center. If Q is a positive number, then my electric field is going away from it. If Q is a negative number, then I'll end up with a negative R hat, which means the electric field is going towards it. Negative unit vector just means opposite direction of that one's defined. So if I have a charge going, if I have an electric field going to the right here, I could have a positive charge over there creating it. I could have a negative charge on the right side creating it, or just the combination of the two. I've got a positive and negative charge as such. Any one of these situations would create an electric field going to the right.
But if the positive is on the other side, it would be a negative R hat.
Well, it's still, this would be positive R hat where that's the center. If I put the positive charge over here, then it's still positive R hat from the positive charge, still going away from the positive charge.
Put that as the origin, like it still would be.
Yeah, the location of Q is the origin in this situation here. So if my charge is here, I have an electric field going in all directions, it's away.
Oh, it's always positive. So if it's, okay, if it's a negative charge and it's going towards the charge, then it's a negative R hat?
Yes. Okay. And that comes out straight in the math. You plug it, because if Q is negative, you plug a negative in there, you automatically get the negative popping out. If I put a negative charge here, which way will it be forced? Okay, I've seen two people point in the correct direction. So I put a positive charge here, negative charge here, you're saying the negative charge will be forced, some people are saying to the right, I've seen shaking no's, some saying to the left. Right, and if I, up, it won't be up. Ignoring electric field. If I have a positive and a negative charge there, which way will the negative charge be forced? Yeah, it'll be forced towards that. If I put a negative charge here, which way will it be forced? I put a negative charge here, which way will it be forced? So in all three of these situations, I have an electric field going to the right, the negative electron, or the electron, will be forced to the left. I can then take it one step further. I have an electric field going this way. I have no idea how it's created. I just have an electric field and I put a negative charge into it. Which way will the negative charge be forced?
So can we say that the electron will move opposite to the electric field?
More generally, a negative charge will move opposite. And so this is one of the rules, is that in the presence of an electric field, negative charge moves upstream. Not the official word. Opposite direction of the electric field. So we have two parts to this, and likewise, if I put a positive charge here, which way would the positive charge be forced? And here too, and here too. In the presence of an electric field, positive charge moves downstream, or in the direction of the electric field. That, in combination of the electric field produced by positive charge, is away from positive charge. The electric field produced by negative charge is toward negative charge. So we have a second explanation for why opposites attract or like repels. The first one is just, that's the nature of it, opposite charges attract. But if I have a negative charge, it produces an electric field heading towards it. If I put a negative charge in near that, that negative charge is going to go upstream or away from the negative charge. If I put a positive charge in there, it's going to go in the direction of the positive charge or towards the negative. So if I have a negative charge here, I have electric field lines that go towards it. I put a positive charge into that presence. I know positive charges will move in the direction of the electric field, in other words, towards the negative charge. If I put a negative charge here, it will go upstream, it'll go opposite. So we have a second way of explaining opposite attract like repels. And you're probably thinking at this point, wow, that's great. Are there other ways of doing it? You're on thought, there are. There are 4 ways of explaining the exact same thing. You might also be thinking, why 4? Why can't we just settle for 1? Because force and energy are 2 of the ways that we dealt with it in 251. We're more apt to deal with 2 other things instead of force. Yes, you can do everything in terms of force, but sometimes it's not convenient. And as we get to more and more complex systems, dealing with forces becomes much more difficult, or energy becomes more difficult. And so there are other ways of looking at the same thing. So at some point, electric field will become more important than force. Questions here?
If there was 2 negative or 2 positive on each side, would it just stay in the middle? Would it move at all?
So if I had positive, 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 positive,
Yeah.
if I put a negative charge there, if I put it smack dab in the middle, it would stay exactly where it is. So if I had a negative, negative, negative here, it's being repelled by both. This would be a stable equilibrium, because if you nudged it, it would just get forced back into the middle. This would be an unstable equilibrium, so if you nudged it, it would now, it's closer to one of the positive charges than the other, and it would just keep going.
Okay.
But it is possible to put an equilibrium in both cases, assuming these outside charges are fixed. Let's just do a simple little problem. I have some charge of, let's just say, 3 nanocoulombs right here. From a distance 4 meters away. What is the electric field? We'll call that point P. What is the electric field at point P? Because of that 3 nanocoulomb charge. So, straight up plug and jug. I have 9 times 10 to the 9. Meter squared, coulomb squared. Times the charge, 3 times 10 to the negative 9 coulombs over 4 meters squared. And we end up with, well, for your fraction fans, 27/16 units.
Newtons per coulomb.
1.6 what?
1.6875
And units?
newtons per coulomb.
Yep. And what are we missing for the final answer?
The R100.
Yeah. If I wanted just the magnitude, I would either say, what is the magnitude or of the electric field, or what is the electric field strength? I say electric field strength. Oh, which does remind me, on the homework quiz, if you go under module 1, chapter 23, there's the flash information, which should be, I think, the first item,
Flashcards?
the flashcards. The quiz officially will be 3 questions. The first question is gonna be the flash quiz, that is timed 10 minutes and done. So it's gonna be, I'm gonna ask you stuff that I'm expecting you to have memorized off the flashcards and be able to regurgitate it down on paper. It used to be 6 minutes, but I extended it because the format is slightly different. I clump things together.
So that is a conceptual. That is a.
That is conceptual.
It's the
Yes.
ones where like, you can print them and there's little squares, right?
Yeah,
Okay.
yeah, and if it's printed double-sided, you should be able to just cut it and the answer should be right on the back.
Okay.
Is it multiple choice or is it like fill in? Like-
Fill in, it'll,
Right,
yeah,
it's
not-
like straight from the flashcards.
yeah, there's no interpretation of the flash quiz, there's no interpretation of it, it's just, you know, what is Google constant, like the units, which are the following vectors. I guess that's sort of a multiple choice. But what's the formula for, yeah, whatever it's on the quiz, but whatever's on the flashcards. Right. Questions on this or the other thing we just revealed? All right, let's. Dealing with numbers, having the calculator exercise is fine, but I know you're thirsting for something that you can't use a calculator on. So let's do something that you can't use a calculator. So change that. All right, so we're gonna take 2 charges here. Distance S between them. That's a positive charge, that's a negative charge, so we'll say positive Q and negative Q. A point P over here.